This is segment 8 of the Module 7 lecture. In this part, we're going to review two examples of how to calculate the confidence interval and how to interpret it. In the first example, we have a researcher that randomly selected 16 coffee shops of a particular chain and measures the temperature of the coffee sold at each shop. So the sample mean, from these 16 observations, he finds that the sample mean is 162 degrees Fahrenheit and the sample standard deviation is 10 degrees Fahrenheit. So his researcher wants to find the 95% confidence interval for the mean temperature. And we are told to assume that the temperatures are approximately normally distributed. This assumption makes sense because most of these coffee machines have a temperature controller, so they keep the coffee at a set temperature with random variations in the temperature, and that random variation can be assumed to follow normal distribution. All right, so that's a reasonable assumption. All right, so when you solve these kind of problems, I recommend that you follow this order. So number one, summarize the information. Make sure you understand what each piece of information given to you in the problem. And typically these problems give you the sample size, give you the sample mean, they give you the sample standard deviation, and they give you the confidence level. That's the information that we need to construct the confidence interval. The second piece of information is what can we use the t-distribution to construct the confidence interval. For that, you need to verify two assumptions. Number one, is the sampling distribution of the mean normal? In this case, that they tell us that the population distribution is normal. Then we know by the central limit theorem that the sampling distribution of the mean is normal. Now, for us to use the t-distribution, we need the sampling distribution of the mean be normal, but also we need to use the sample standard deviation. And we're going to do that because the population standard deviation is unknown. So yes, we can use the t-distribution. All right. In step 3, we want to find the t-value that we're going to use in the calculation of the confidence interval. So we use the level of confidence, which in this case is 95%. Then alpha is 0.05, and remember this 0.05, which is the probability to remain outside the 0.95, we divide it equally between the two tails. So that 0.05 divided by 2 is 0.025. So we're going to use this probability of 0.025 that comes from the confidence level, and the degrees of freedom, which is the sample size minus 1, in this case 15. With these degrees of freedom and this probability, we enter table 5, and then we find the t-value to be 2.131. So now we're going to use that t-value, the sample mean, the sample standard deviation, and the square root of the sample size, and the t-value that we just found. So we, using the equations that I showed earlier, we calculate the upper limit of the confidence interval, and then we calculate the lower limit of the confidence interval. Once you find the values for the limits of the confidence interval, then the last step is to interpret that confidence interval. So based on what I explained earlier, we can say then that the mean temperature of the coffee sold at all the coffee shops of this chain is between 156.7 degrees Fahrenheit and 167.3 degrees Fahrenheit with 95% confidence level. All right, notice that I am quoting the units of measurement because they are very important to see in what scale the temperature was measured. All right, so this is the first example. Let's look at the second example. In this case, a manufacturing company produces electric insulators, and these are the ceramic electric insulators. Here's a picture of it. And the variable of interest is the strength of the insulator. Because if this insulator breaks, then the cables come together and there is a short circuit. So the strength is a key characteristic of these insulators. And they test the strength of these insulators through a destructive test where they compress them and twist them and to see how much force it takes to break them. And that force is measured in newtons. So in this example, 30 insulators were randomly selected and tested. And from those, the result of those tests, the sample mean was found to be 1,723.4 newtons, and the standard deviation of that sample to be 89.551 newtons. So, and here we want to construct a 99% confidence interval estimate of the mean strength of the population of insulators. All right. So again, follow the steps that I outlined in the previous example. Number one, summarize the information. This is an important step to ensure that you identify the information given to you correctly so that you can enter correctly into the equations for the confidence interval limits. So do you have the sample size, you have the sample mean, the sample standard deviation, and the confidence level. These are the 4 pieces of information that you're going to use in the equation of the confidence interval to compute the confidence interval limits. The second one is to justify the use of the t-distribution. In this case, they don't tell us anything about the population distribution of the strength of the insulators, but they tell us that the sample size is 30. So relying on the central limit theorem, because the sample size is 30, then we can say we can safely assume that the sampling distribution of the mean is normal. Now, the population standard deviation is not known, and we're going to use the sample standard deviation, which is known right here. So with those 2 things, then we know that we're justified in using the t-distribution to construct this confidence interval. All right, so the next step 3, is to find the value, the t-value to use in the confidence interval equations. So in here we use the level of confidence, which is 99%. From there we can see that alpha is 0.01. Remember, this alpha probability is divided between the 2 tails in an equal fashion. So we divide 0.01 by 2, and that gives you 0.005. So we're going to use that probability and the degrees of freedom, which is the sample size minus 129. And with those 2 pieces of information, the probability and the degrees of freedom, we go into table 5 and we find the t-value, which is 2.756. Please use your table and verify this value. Make sure that that is correct so that you practice using the table 5. All right, so now we know the t-value, we know the mean, the standard deviation, and the sample size. So we replace all those values into the equation. We carry out the calculation, and we find the upper limit of the confidence interval. And then using this equation, we find the lower limit of the confidence interval. So now that we have the limits of the confidence interval, we proceed to interpret the confidence interval. So then we can say that there is a 95% confidence level that the average strength of all insulators is between 1,678.43 and 1,768.46 newtons. And if you have taken physics, you might remember that newtons is just kilograms times meter divided by the second square. All right, so these are the 2 examples I wanted to review with you to calculate confidence interval limits. So they are not difficult to calculate, but I recommend that you do it in an orderly fashion so that you prevent mistakes. And also remember these 4 steps. And don't forget the last step. Once you calculate the confidence interval limit or limits, you need to interpret that interval. That's the key piece of doing all that, the interpretation of the confidence interval. Because based on this interpretation, you can make recommendations for changing the process or improving the process, or for making decisions of buying this company because it has a good product, or whatever the situation that might be. But without that interpretation, making recommendations or making a decision will be very difficult. So please remember to interpret the results. All right, we'll stop here, and in the next section, we'll start talking about the confidence interval for the proportions.